Welcome. I'm glad you've joined me today to learn more about developing science vocabulary as a part of the sense-making process. I'm Patty Works, and this video is brought to you by PIMSR, the Partnership Institute for Mathematics and Science Education Reform. As you participate in this video workshop, it can be used individually or with a grade level group or PLC. You'll want to have access to the following materials as we get ready to get started today. You'll have electronic resources. The readings are linked in the description box below. And you'll also want a note taker, either an electronic document or paper and pen. This video is the second part in our vocabulary series. If you haven't worked through the first video, you might want to engage in that work first. In video 1, we looked at how and when to develop procedural and conceptual vocabulary in a sense-making sequence or unit in science. Here are our objectives for this science vocabulary two-part series. In the first video, we learned how to plan for authentic vocabulary development within a phenomenon-driven lesson sequence where students were figuring out about science concepts. And in this second video, we'll look at working on ways to increase the vocabulary development tools and strategies in your teacher toolkit. During our time together, we'll explore the following questions. How can I effectively plan an interactive word wall to support vocabulary development and usage? Then we'll look at what are some strategies to interest students in new words and their meanings. What are some strategies to help students use new phenomena-related words and phrases in speaking and writing? And what are some strategies to help collect formative information about students' understanding of that conceptual vocabulary? To preview where we're heading in this sequence, here's what this video session will include. We're going to start out with a brief review of video 1, thinking about vocabulary in the sense-making process. If you haven't watched video 1, we'd recommend you start there. Then we'll look at interactive word walls. What should they contain and when are they built? We'll work with strategies to build interest in upcoming vocabulary, specifically the vocabulary knowledge rating and word cloud strategies. And then we're going to look at how you can build phenomena-related words and phrases in student conversation and writing with explanation language frames, word catchers, personal glossary, and reading science text cards. We'll also look at strategies to collect information on conceptual vocabulary knowledge, such as the Freire model, word relationships, and concept card mapping. While some of these strategies are tried and true vocabulary builders that have stood the test of time, thinking about when to use each strategy and really planning to use an activity strategically will be the focus of this video. Often in the course of teaching, we don't stop to plan ahead for a strategy that will have the biggest impact at a certain point in learning. So how do we go about selecting a strategy that will have the desired results? And what evidence do we have that it works? This video is also designed to be used as best meets your needs, working with a PLC group or with a grade level team. After each focus question, strategies will be introduced, and then there's a suggested pause point where you can go into the resources linked below, read more about the strategy, and then plan for how and when you'd like to use it. The strategies that we highlight here are really just the tip of the iceberg. We hope you'll take the opportunity to pause the video and share other ideas of your own with your team. What works for you and your students to authentically learn science terms? And what strategies yield the best evidence of learning with your classes? This video is the second one in a series about authentic vocabulary development. In video 1, we looked at how to plan for vocabulary in the sense-making sequence. First, the teacher's going to think about what science concepts and standards they want to cover. Then they'll select a phenomenon to drive the learning. That phenomena is an observable event in nature that we can use science ideas to predict or explain. Once the phenomena is selected, The teacher is going to think about choosing experiences, experiments, and readings for students to collect evidence to answer the focus questions. Within these experiences, we want to think about which science and engineering practices and cross-cutting concepts will help students as they gather evidence and make sense of it. Then, looking at those experiences and the learning that's going to be occurring, you can think about which scientific terminology will help students communicate with precise language. Last session, we talked about different types of vocabulary our students will use as they build science ideas and understandings. The first type of vocabulary, procedural vocabulary, it is the vocabulary that students need to participate in an investigation as they begin to explore. This might include the names of certain key tools or materials. The second type of vocabulary is the vocabulary that students develop that consists of terms that describe complex ideas or processes, such as erosion, electric current, adaptations, waves, or ecosystems. Procedural vocabulary, the vocabulary that students need to engage in learning activities, can be pre-taught or front-loaded. For example, if students are following directions to set up an aquarium, you might need to introduce terms like guppy, tadpole, duckweed, and graduated cylinder before they begin. Conceptual vocabulary involves complex ideas or processes. These terms are often abstract and difficult to understand through a definition alone. It's best to introduce them when students have developed a context and connection to the ideas through experiences. With our aquarium example, after students have observed the interactions and processes occurring, they have a much better understanding and a need for specific terms to use in communication. Last session, we took a quick peek at a word wall developed for a lesson sequence. Today, we're going to learn more details about how to go through that process yourself. First, we're going to look at what a couple of sources have to say about when you want to add a term to the class word wall. In How Students Learn Science, published by the National Research Council, they state, "This is a caveat in inquiry-based science. Students must learn scientific vocabulary after they have had a concrete experience." And Donovan and Bransford wrote, "Ideas develop from experiences and technical terms develop from the ideas and operations that are rooted in these experiences. When terms come first, students just tend to memorize so much technical jargon that it sloughs off in a while. We've all been there. How many times have we memorized a definition only to realize we forgot it right after the test?" Betsy Rupfel-Weiler, the author of Writing in Science, How to Scaffold Instruction to Support Learning, has this to say: "Place a word in the word bank after students have had a concrete experience with something and they have a need to know the appropriate term." During session 1, we walked through a second grade sense-making sequence where students were trying to figure out the phenomenon of a plant starting to grow in an unusual space where we knew a seed was not intentionally planted. This is the photo of the interactive word wall developed for that seed dispersal sequence. The word wall should be built during the learning as students encounter words that they need to use as they're thinking and communicating like scientists. The focus question is shown there in the center of the word wall, and you'll notice that there are sections on the word wall that include vocabulary from the focal science and engineering practices and cross-cutting concepts. The words are organized into categories for easy retrieval, and they've been illustrated with student drawings, pictures, and real objects or realia that make the word visually accessible to students. In this section of the video, we'll talk through what's important to have in a word wall. We want students to have multiple experiences using the words in speaking and writing to make them their own. So why are visuals so important in learning new vocabulary? Well, let's look at what some studies show. Visual associations with a word result in significantly better recall of that vocabulary. That was from Kumyumjan in 2013. Students remembered nearly all new words when they encountered them with audio or visual aids. That's from Sola's research in 2014. And depending on the studies that you read, the brain processes visual information many times faster than text. Glancing at an unknown word when it's accompanied by a visual really helps make retrieval of that word much faster. And in my experience, learning using different modalities is really key in the vocabulary development process. Julie Jackson, an associate professor at Texas State, developed the rubric you see on this slide for evaluating the usefulness of a word wall. Dr. Jackson's research interests include integrating literacy and science, vocabulary development, and effective science instruction for English language learners. She has a website, thesciencetoolkit.com, where the articles that she's published in NSTA journals are posted. This rubric is in an article in your resources titled Interactive Word Walls, which was published in Science and Children. Dr. Jackson uses word walls throughout elementary and middle school, and the other article of hers that's in your resources is from Science Scope. It lays out the steps in developing and using word walls in class. As Dr. Jackson went into the classrooms she was using for her research, she wanted this rubric to be instructive, to help show teachers how they could make their word walls more effective for students. She divided the attributes into 3 categories: good, better, and best. The basic category, good, includes posted academic vocabulary. It also has words that are aligned with current instruction and words that are visible from a distance. You notice that those same 3 categories are also included in the better and best categories. So take a moment and pause the video here. What makes a word fall into the better category? How are the criteria for best even different than those in better? Well, you probably noted that in both the better and best categories, the words are arranged to illustrate relationships and organized learning. The better category notes that the word wall may contain student-generated material. With a best word wall, there's definitely student-generated material like word cards, illustrations, or collected objects. In the better word wall, we see that there are visual supports, although they may be in black and white. The best category has color pictures, photos, or realia. You may want to access this rubric in your resources to look at some examples of word walls on the next few slides. So take a second and find that rubric on your own, and we'll apply it as we continue. Well, here's a sample word wall that students used to describe characteristics of soil that they'd explored. Using the rubric, how would you rate this word wall? Good, better, or best? And what evidence might help you determine which category? If you're working with a group, you may want to pause and discuss how this word wall fares on Jackson's rubric. Well, as I see, the words are arranged in categories here to help them be able to find texture words, color and particle size words. There are some student-generated word cards and visual supports, and those are in color. There's even some little soil samples that are glued right onto the index cards here. So I think this one would fall within that best category. Okay, so what are your thoughts on this word wall? And what might you suggest to this teacher? Well, it looks like these words may not all be from current units, and without any visuals to support them or without any organization, it would be pretty hard for a student to locate a word on this word wall. Here's a word wall that's organized in a pocket chart. Students were studying bodies of water and landforms. So how would you rate this word wall? Are the words organized in a way that would help students find them? Does there appear to be any student-generated work or color on the word wall? One idea that Dr. Jackson suggests can be an easy way to include color visuals in student work is for a teacher to have a stack of index cards or little pieces of scratch paper, and then as a word needs to be illustrated and added to the word wall, you can ask students to draw and illustrate the words and put them up on the wall. That's a time-saving solution. It gives you color and student work and visuals all at one time. Another space-saving way to include a word wall when wall space is hard to come by is to use a trifold board. This also works well for middle school classes where different grades or sections may be building different vocabulary walls. When one class concludes, you can fold it up and tuck it away until the next time the class meets. This word wall really shows relationships between different materials, their properties, and regions. I love the way the students have drawn arrows and made connections to show their understanding of how these words fit together. Again, this word wall shows evidence of students putting concepts together after having learned about producers, consumers, and food webs. Notice the sentence scaffolds that are helpful to students as they use the vocabulary and context. So looking back at our word wall from the seed dispersal sequence, let's think about this one. Please note that it was driven by the answering that focus question right there in the center. I had looked through the unit ahead of time and thought about the terms that I wanted students to be able to use as they spoke and wrote. And I organized those words into 6 different groups for easy retrieval. General terms are in that upper left-hand corner, science practices terms, cross-cutting concepts, and then 3 dispersal groups along the bottom there showing wind, water, and the animal interaction vocabulary. There are color photos and drawings, some real objects in bags, and there are student illustrations and student work included. So why are visuals so important? Well, think about the story of the Starbucks logo. The Starbucks logo is instantly recognized with or without the store name. And in recent years, the store signs just show the visual. You actually recognize it much faster without the word being on the sign. So to summarize, the use of photos, illustrations, icons, and realia decreases learning time, improves comprehension, helps with information retrieval, and it increases the retention of material. That's kind of a pretty good list of things that we hope are happening as we're teaching our students science terminology. So as a teacher, I always felt like I was best supported when I could see lots of examples. So let's take a minute to watch a video that will show you that. It outlines the steps to plan and build a word wall with your students, and it highlights lots of examples at various grade levels. Note that these word walls were built by Texas teachers who use the Texas standards. So the word walls may look a little different, or like they're studying things at different grade levels than the standards that we use here in Kentucky. So as you're watching, kind of note how these word walls vary. What elements have they included? The steps that are outlined in the upcoming video are also in your second article by Julie Jackson in your resources. So don't feel as if you have to write down all these steps during the video. They'll be right there in your article. The steps that you just saw in this video were outlined in Julie Jackson's article as well from the sciencetoolkit.com. The article is linked in the description box below as Steps for Interactive Word Walls. This might be a good time to pause the video and find the word wall articles. How could you organize a word wall and a student organizer to be built during instruction? Remember to use the steps that are outlined in the article. Step 1, you're planning the word wall, determining what vocabulary needs you have, and making a graphic organizer or a concept map format that you'd like to use. Step 2, create a matching student organizer. Students will be getting a blank copy of that graphic where they can fill in the words to match the word wall as they're added in the context of the learning and the lessons. Then you're going to place the word wall frame or outline somewhere in your room. And step 4 is building the wall in class during the course of the lessons. And then as the wall is built, students are also completing their matching organizer so they have the same copy of it. This might be a place that your group or PLC would decide to pause the video and spend some time actually going through these steps and thinking about how you'd like to design a word wall for your next unit or lesson sequence. We would love it if you develop one, if you were willing to share and send us a picture of what it looks like to PIMSR. Now let's dig into our second focus question. What are some strategies to interest students in new words and their meanings? As we review these strategies, let's be really intentional about how we're selecting them. And we'll think about these things. What does the strategy involve? When might you choose to use the strategy? And how would the strategy help students internalize new vocabulary? The first strategy we're going to look at is called the vocabulary knowledge rating. In this strategy, teachers select words that are going to be needed in upcoming instruction, and those are listed in the left-hand column. Students check one of the next two boxes. I've never heard of this or heard it. And then in the have some idea column, they write or illustrate what they think they know about the word in their own language. In the know it well column, they write down their definition of the word once they're fairly sure of the meaning. This should be using their own wording and vocabulary. This is linked in the description box below, so you can see this format, and it comes from the website shown on the slide, adapted from the work of Blokovic and Fisher. When might you use this strategy? Well, you could use it before a piece of complex text is introduced, or it could be used at the beginning of a unit to formatively assess student vocabulary knowledge and create interest in vocabulary in upcoming lessons. It can be revisited at various points throughout the unit for students to revise and add ideas. How would this strategy help students internalize new vocabulary? Well, for one thing, it can really stimulate curiosity about a word and what it means. And it also encourages students to define a word in their own terms and to revise and revisit their ideas. This is also a great assessment for learning, and it can provide valuable information to the teacher about the student's understanding. Be sure you have students use pencils on this, not pens. I've seen students pull this page back out of their science notebook again and again to revise. Now we're going to take a minute to watch an 8th grade science teacher, Peter Hill, describe a way that he stimulates student curiosity about vocabulary. We're going to watch a video, Literacy in Science, Word Clouds, which is from the Teaching Channel. In a word cloud, higher frequency words are larger than other vocabulary.
As a science teacher, I think it's important to teach literacy skills too, so that you can read a newspaper article, figure out the science behind it. One thing I love to do is use word clouds. Okay, so here's what we're gonna do. Brandon, you cool if we use you first? Basically, you take an article and then you put it into this computer program and it generates a word cloud where the size of the words emphasizes their frequency, how often they show up in the article. So what I'll do is I'll make a word cloud of an article ahead of time and give it to the kids before we do a reading and have kids anticipate, what's this reading going to be about? What are the main ideas? And then what's a weird word that you see that you don't know? And I think all those like little quick activities, you do that 5 minutes before a reading, it gets the kids engaged in the reading, it gets them curious about what they're going to read.
Okay, so we saw a little bit about what this strategy involves. First of all, you need to make a word cloud, okay? So you're going to select a piece of text that you're wanting to use with your class and use that to generate a word cloud. There are several different online sites that can help you do that from a PDF document. So the teacher will create a word cloud, and that helps show which words are most commonly occurring in a piece of informational text. Then it's presented to the students as an anticipatory activity. The teacher also asks students to try to infer what the article is about. What are the main ideas of this piece of text or book? And what unfamiliar words do they see in the cloud? Also, another option you might want to consider is the Mentimeter will allow you to poll students, and they can submit unknown words, which could help you make a live word cloud of things that your students are wondering about. When might you use this strategy? Well, before a piece of complex text is introduced, you could use it, or at the beginning of a lesson sequence to formatively assess student vocabulary knowledge or how well they're able to infer about text. There's also a website that will let you take a vocal recording of group discussion and analyze it into a word cloud. That would be a great way to motivate your students to use the scientific terminology they've developed in the classroom. So how might this strategy help alert students to new vocabulary? Well, they'll see the vocabulary in the word cloud in isolation. So it may be easier to recognize words that are unfamiliar when they're not relying on sentence context. They get the opportunity in a collaborative classroom here to share questions about vocabulary and then predict and infer about their meanings. The next step is to think of a strategy that you'd like to use to pique curiosity in new words with your class. Your team may have other strategies you want to share at this point. What's worked well for you? What evidence supports using that strategy? You may want to pause the video now and find out more about these strategies, and then plan to use one soon at an appropriate time when your focus is really on helping students access complex text. So you've got two different strategies to think about learning more. The vocabulary knowledge rating, you could look at a unit or a lesson sequence, select which words you want to use with your students, and then plan for when you're going to implement and formatively assess their knowledge. And you could also work on using the word cloud introduction to text vocabulary, where you select some text and create a word cloud, and then allow students to wonder what words mean, what's unfamiliar, and plan some questions for them to see if they can infer what that piece may be about. So next, we're going to explore what are some strategies to help students use new phenomena-related words and phrases in speaking and writing. What does this strategy involve? Explanation language frames or sentence structure frames are a commonly used technique that involves providing students with a scaffolded sentence structure to help them complete scientific writing for different purposes. They can take many forms, and they're helpful with using new vocabulary in speaking and writing. You can find sources of these within lessons in many curriculum resources and in books and on websites about writing in science and science notebooking. They're often interchangeable with various discourse frames too. So this is a gradual release strategy that provides students with a structure to frame their thinking. For example, in the previous seed dispersal lesson sequence that we looked at in video 1, the teacher might provide the following frames. Seeds may blank by floating in the water, blank in the wind, or being moved by blank. So to recap this strategy, the teacher is providing sentence scaffolds for students to practice using the vocabulary in the context of sentences. It provides specific sentence structures for science content that may differ from more common language. And different sentence structure frames are provided for scientific language functions like making observations, comparing, and providing evidence. Betsy Rupfel-Weiler, the author of Writing in Science, How to Scaffold Instruction to Support Learning, provides a lot of sentence frames for various types of writing in her book. Those frames can be made into a poster, like you see here. There are scaffolds for asking questions, making observations, comparisons, sequencing your thoughts, looking at cause and effect relationships, writing claims, describing your evidence, reasoning, and conclusions. The goal with the use of sentence frames is to help scaffold students' use of scientific talk. And with continued practice, you'll be able to remove these supports as students no longer need them. So when might you use this strategy? When vocabulary has been introduced in context and you want kids to practice using it appropriately, either in speech or in writing in complete sentences. You might use this strategy when you want students to use specific vocabulary to describe scientific processes, make observations or explanations. It can be used to provide evidence and reasoning to support a claim, or encouraging students to use text or investigation evidence when they're backing up their ideas. And then it can also be used when you're teaching argumentation skills, which may be uncomfortable for some students initially pushing back on someone else's ideas. So how would the strategy help students learn to use new vocabulary? Well, it can empower everyone by giving them an entry point into the conversation, and it gives them a structure to respond to questions. They can also use the new vocabulary appropriately in a scientific sentence. It can help create a class culture of compassion and peer support as students are building their vocabulary. Remember that we really want to encourage kids to gradually move towards the use of specialized language and encourage their own authentic use of language until they've reached that point. What does the strategy involve? Word catchers are co-constructed between teachers and students. They contain phenomena-related words and phrases to support sense-making. They might include pictures, student-developed explanations, and example phrases. These can be done electronically on slides or on Google Sheets, or they can be physically posted around the room in various spots to support discourse and writing. And this strategy of word catchers is from STEM Teaching Tools number 66 at the website stemteachingtools.org. We looked at this document more carefully in video 1 resources. The word catchers PDF is a link in STEM Teaching Tools number 66. So when might you use this strategy? It's a good strategy to use during the early stages of making sense of a phenomenon or an engineering problem that students are working to solve. It can be used as students are learning new procedural vocabulary or as they're starting to develop conceptual vocabulary. And when you want to create a public knowledge base for students to have up around your room or in a digital format, it's a great thing for students to be able to collaborate and use that together. How would this strategy help students internalize vocabulary? Well, kids are adding the words or phrases that they feel are helpful in communication and putting them up at various spots around the room, sharing their knowledge base and their reasoning. And it can help students by helping them collaboratively construct meaning and share their understanding of how to communicate scientifically in a variety of different formats. So these word catchers can be pretty informal and have different looks to them as students gain vocabulary skills working together. Okay, so now we're going to take a look at personal glossary. Okay, and this strategy is also in your resources. This was developed by BSCS Science Learning. So what is a personal glossary? Well, students start keeping their own personal glossary in the back of their science notebook, and they add into it words that are unfamiliar or phrases that are unfamiliar to them. Students keep their own personal glossary, and as they develop definitions in their own words, they add those in along with any notes as far as pronunciation, whatever. Students can also record any personal connections or thoughts they have, previous experiences, something that happened in a lesson that would help remind them of the meaning of that word. And I would encourage them to sketch or draw to illustrate those ideas as well. You see a little example of what this might look like and the form it could take there in the screenshot of the article. So that strategy is in your resources for video 2. When might you use this? Well, after you've set up a personal glossary in the back of your notebook, students might choose to add words into the glossary at different points. Whenever they're in the middle of an investigation, if they're reading and run into an unfamiliar word, during discussions, if they hear a new word, they can add that into their glossary. And then they've got it there to use when they're developing and using models or explanations. How would the strategy help students internalize new vocabulary? Well, it could help them by making a personal connection to that word. Students are often reminded of activities and experiences that they've had that would help them understand the meaning. The words are self-selected, so students have acknowledged it's a word they're not familiar with, so you've got an automatic need to know going on in their heads there. And the list is kept there in their science notebook, so it's really available to students in class, or if they take their notebook home, they could use it as well for more research or for homework. In your resources, there's an article called Effective Strategies for Teaching Science Vocabulary that lists a variety of science text activities that you might want to look through. True-false cards and agree-disagree cards are just 2 examples of activities that really stuck out to me. You can ask students to provide evidence to support their answers on these. So with true-false cards, students draw cards that the teacher has created. So for instance, if we were using that seed dispersal example, a card might read, "One way that seeds get dispersed is through animal droppings, true or false?" What evidence do you have to support your answer? Vocabulary words like dispersed or droppings are intentionally embedded into the statements. With agree-disagree cards, students could write a specific statement that includes a vocabulary word on a card. The teachers could also write and make those statement cards up ahead of time. Then students state whether they agree or disagree with the statement and provide evidence to support their answer. Another variation of this could be to have students write the statements on either one of these activities, and after the teacher has read through the statements, you could produce a deck from student-generated sentences to share with everyone to have all students respond to. In matching pairs, students are matching vocabulary words to the function, common use, meaning, or an illustration that might match that vocabulary. Now it's time to pause and reflect a little bit on how and when you might use some of these strategies in your upcoming lessons. Please take this time as an opportunity to share other strategies with your team that you found to be successful in your classroom. How did your students respond, and what evidence did you see of that strategy being successful? So plan to use a strategy that you'd like to try in class that meets the needs of your group. So on the screen, you see some suggestions of different things you could do here with explanation language frames, word catchers, personal glossary, or with the Georgia Department of Ed Vocabulary Strategies Toolbox article. Pause and try out one of these and then restart the video when you're ready to go on. Now we're ready to answer this last focus question. What are some strategies to help collect formative information about student understanding of conceptual vocabulary? The Frayer model. The Frayer model is a strategy that's been in use for a long time, and it can be very effective when it's used selectively. It involves students using this strategy, which was developed by Dorothy Frayer and her colleagues at the University of Wisconsin, to help provide a thorough understanding of new words. Students provide a definition of the word, then they look at facts and characteristics of the word, and come up with some examples and some non-examples. This can lead students to a deeper understanding of the word and its relationship to their own lives. So when might you use this strategy? The strategy can be used at different points in the learning. Students could complete parts of the model as they learn about a new word and revisit the model with additional examples or non-examples. Or it can be used with conceptual vocabulary after they've had experiences that have led to a deeper understanding. How would this help kids internalize new vocabulary? Well, by providing examples and non-examples, students are fully developing what a conceptual vocabulary word means to them. They're adding examples that have meaning specifically to them from experiences they've had, either in lessons or in their personal lives. It can also help them internalize new vocabulary by adding characteristics of the word that can help them broaden or zero in on aspects of the definition. They might think about usage as they think about what part of speech it is, and relate the word to other key science concepts. The definition often includes a given definition, followed by the definition being written in their students' own words. So that's a great way for the teacher to see if the student developed definition really reflects accurate ideas. Okay, the next strategy is called word relationships. Students are given word cards in this activity with conceptual vocabulary words on individual cards, like you see here. They are tasked with combining 2 or more words in a sentence to show their understanding of how the words relate to each other. Depending on needs, different groups of students can get either the same cards or different sets of word cards, and then they can record and illustrate their sentences, creating questions or statements. Students can work collaboratively in pairs and share their sentences with a small group or with the class, and then collectively record sentences that match their understanding of the concepts. Using a think, pair, share model can be helpful to let students get their ideas aired with a partner before going public with the group. When might you use this word relationship strategy? You can use it after students have a pretty strong grasp on the conceptual vocabulary. So this could be after a lesson sequence or near the end of a unit. You can use it when you want to see how students can combine concepts and share ideas collaboratively before a summative assessment. How would this strategy help students internalize new vocabulary? Well, they can run ideas by a partner and collaboratively develop sentences looking at the meaning and relationship between words. They'll hear and read sentences that their classmates construct, and that can help them evaluate and refine their own thinking. This activity can also help them recognize patterns and identify relationships between words, building upon more complex ideas. Various authors of this strategy can be found, and it is used in some curriculums like Amplify Science, as well as others. The last strategy we're going to look at today is called concept card mapping. So what does this strategy involve? Students are given cards with conceptual vocabulary printed on them. They move the cards around and arrange them to make an interconnected web of knowledge, a graphic organizer of sorts. They can create linkages between cards to show relationships between concepts, as well as group the cards in different ways to show relationships. You might use this strategy at key points within a lesson sequence to see how students can make linkages between vocabulary and conceptual ideas. You could use it near the end of a unit of study when you're ready to assess their understanding. And it can also be used to elicit ideas and relationships between concepts prior to beginning a science unit. And then let students go back, revisit, revise their concept card relationships as they learn more. It also works well with words or phrases that describe processes or cycles. So while a word wall is graphically organized, you as the teacher have decided how to arrange the words in that word wall. In concept card mapping, students show their understanding of relationships between terms in this strategy in their own ways. How would this strategy help students internalize new vocabulary? Well, it's going to help them activate prior knowledge. It's also going to help students use the vocabulary in the context of linking it to other conceptual words. It can promote discussion and idea sharing between classmates because there's no one right answer here. And it can also help students consider other people's ideas. And as they consider other people's ideas, that may deepen their understanding of the conceptual vocabulary word. So now select a strategy that you would like to try with your class to cement conceptual vocabulary. There are readings in the folder on word relationships and concept card mapping. Pause the video and think about which words you'll want to include on cards for word relationships or concept card mapping in an upcoming unit. There are numerous Frayer model resources and examples that you can find online. This vocabulary series aimed to meet these goals. First, we learned how to plan for authentic vocabulary development within a phenomena-driven lesson sequence, where students were figuring out science concepts in video 1. We looked at the way that NGSS units are developed from the standards, targeting key concepts in a phenomena-driven lesson sequence or unit. As the teacher plans the activities for students to collect evidence and the reflection opportunities in the sense-making process, we looked at selecting key vocabulary that students will need to communicate like scientists. This involved vocabulary from the science and engineering practices as well as the cross-cutting concepts and the disciplinary core ideas. And then in video 2, we work to increase the vocabulary development tools and strategies in your teacher toolkit. In this video, we focused on looking at planning and using word walls, strategies to engage students in deepening their vocabulary strategically at different points in the learning. Thank you so much for watching. I hope as you reflect on how to improve your students' vocabulary that you've found some helpful tools. Here's some ideas of things that may be next steps for you: developing a plan for an interactive word wall and the student organizer for our next unit, trying one of the strategies that's in your resources that we discussed here within the video, and look through the strategies in the articles collected for this session. Plan ahead for how you want to use some of these high impact strategies in your next unit. Thank you.